Hi, this is a video to go over the 713 classwork. So 713 is on solving word problems with proportions. So this first problem says, proportions can be used to solve word problems in which there is a constant rate. It is very important to stay consistent when setting up your proportion. The units must match on each side of the equal sign. Which of the following equations is a valid proportion? It's the second one, because the first one, miles over hours, hours over miles, they have to stay the same. So a helpful hint is to set up a key, which is how I always tell people to do it when writing a proportion, to make sure the units stay consistent. Okay, so this problem says, Pete drove 224 miles in 4 hours on Saturday. If he drives at the same rate on Sunday, how long would it take him to drive 490 miles? So my key is I'm comparing miles to hours. So I'm going to write my proportion as 224 miles over 4 hours should equal 490 miles over X, because miles goes on top. So we cross multiply, I get 224X equals 1,960. Divide both sides by 224. I get 8.75. Since it's a word problem, I have to write a sentence. And I could round, it tells me to round to the nearest tenth. So I could make that 8.8. Since it came out to an even hundredths place, it would be okay if you left it 2. So how long will it take him to drive? It will take 8.8 hours, or about, we could say it's about 8 hours and 45 minutes. The next example says approximately 4 out of 5 students in Mrs. Haynes' 7th grade math class have cell phones. If there are 365 students in the 7th grade, how many would you expect to have a cell phone? So 4 of the students have cell phones out of 5 total students. So my ratio is going to be has phone over total students. So 4 out of 5 should equal, the 365 is the total, X over 365. So I cross multiply and I get 5X equals 1,460. I divide both sides by 5. I get X equals 292. So again, I have to write a sentence. How many would you expect? I would expect 292 students to have cell phones. Next example. A 100-ounce jug of liquid laundry detergent can wash 64 loads of laundry. How many loads could a 150-ounce jug of detergent wash? So I am comparing ounces inside the jug to loads. So my proportion is going to be 100 over 64 equals 150 over X. Cross multiply, I get 100X equals 9,600. Divide both sides by 100. I get X equals 96. So how many loads could it wash? It can wash 96 loads. Okay, next example. It takes 1 1/4 cups of milk to make 8 pancakes. How many cups of milk are needed to make 20 pancakes? So I'm going to say cups to pancakes. So 1 1/4 over 8 equals x over 20. Cross multiply, I get 8x equals 25. Divide both sides by 8. So I get x equals 3.125. But when I go to make a recipe, measuring instruments do not come in decimals, they only come in fractions. So I need to change that back into a fraction. So it's actually 3 1/8. So we need 3 1/8 cups of milk. So you got to make sure that your answer matches what makes the most sense. Okay, for these next set of problems, what you should do is you should try the problem on your own and then pause the video, and then you'll pause the video, try it on your own, and then replay the video. It says Melanie can run around the track 9 times in 28 minutes. At this rate, how many laps can she run in 1 hour and 15 minutes? So it's laps over minutes. We gotta be careful with this one because she does 9 laps in 28 minutes. We wanna know how long in an hour and 15 minutes. So there's 60 minutes in an hour plus 15. So I have to do 60 plus 15, which is 75. So I get x over 75. So I'm gonna get 28x. 75 times 9 equals 675 divided by 28. X equals 24, about 24.1. So she can run 24.1 laps. Or complete laps, we could say 24. All right, so this next one, an online store receives 15 orders per day. At this rate, how many orders can they expect in the month of September? So our ratio is orders per days. So 15 orders per day means I'm doing 15, there's only 1 day in that, equals, I want to know how many in the month of September. September has 30 days, so I'm going to do x over 30. I cross multiply, I get x equals 450. So we can expect 450 orders. Next one says Trey made 12 out of 30 free throw shots on the basketball court. If he attempts 75 free throws, how many could he expect to make? So it's actually free throws over attempts. Sometimes you have to read a little bit into what the problem is trying to get us to do. So he did 12 out of 30. If he does 75, which is the number of attempts, how many can he expect? So we're going to do 30x equals 12 times 75 equals 900. Divide both sides by 30. X equals 30. So how many could he expect? He should expect to make 30 free throws. All right. So the next part of this is scale drawings and models, which we've talked about already before, but in this respect, we can write proportions to help us solve them as well. So a scale drawing or model is used to represent an object that is too big or too small to be shown in its actual size. The dimensions of the object on the scale drawing or model are proportional to the dimensions of the actual object. The scale is the ratio of the size of the model to its actual size. In scale, we always do model to actual when you write the ratio. So it says a scale can have the same units or different units. You can use a scale to find a missing measure on the model or the actual object. Simply set up and solve a proportion. So the scale in a drawing for a new pool is 2 inches equals 7 feet. If the length of the pool on the drawing is 10 inches, what's the actual length of the pool? So I'm going to do, in this case, I'm going to write inches over feet. I could do scale over actual, because another way to represent it. So I'm going to do 2 over 7. The 10 is the scale or the inches over x. So cross multiply, I get 2x equals 70. Divide both sides by 2, I get x equals 35. So the actual length of the pool is 35 feet. Okay, next one. The blueprint for a house uses the scale 1.5 inches equals 2 feet. If the living room is 18 feet long, find its length on the blueprint. So we're going to do, again, inches over feet. So I'm going to do 1.5 over 2 equals x over 18. Cross multiply, I get 2x equals 27. Divide by 2, x equals 13.5. So find the length on the blueprint. So the length on the blueprint is 13.5 inches. Okay, so for this next part, again, you want to pause the video, try the problem on your own, and then check your answer. So a model of a car uses a scale of 2¼ inches equals 3 feet. If the model is 14 inches long, what's the actual length of the car? So again, we're doing inches over feet. So I'm going to do 2¼ over 3 equals 14 over x. So I'm going to do 2¼ x equals 42. Divide by 2 1/4. This is where decimals can come in real handy because you could put the whole exact fraction in. So I get 18.6 repeating. So x equals, I'm going to say 18 2/3. So what's the actual length of the car? The car is 18 2/3 feet long. Last example. The scale on a map reads 2 inches equals 125 miles. If two cities are 4 3/4 inches apart on the map, what's their actual distance? So this time I'm doing inches to miles. So I do 2 over 125 equals 4 3/4 for x. So I get 2x equals 593.75 or 0.34. Divide by 2. I get x equals 296.9 because I round to the nearest tenth. So what is the actual distance? The actual distance is 296.9 miles.